Right, guys, today we are back with another problem, and today's problem is finding the longest valid parenthesis. Okay, so this is an important question. We get asked these questions in many of the exams, and it's one of the questions of strings which you should focus carefully. Okay, it is saying that you will be given a opening parenthesis and a opening parenthesis and a closing parenthesis. Find the length of the longest valid parenthesis substring. A valid parenthesis is the one which starts with the opening and which ends with the closing parenthesis. Okay, so if I check the length of the valid parenthesis over here, if I check the length of the valid parenthesis over here, what I can see is a valid parenthesis is one which is opens as well as close. So this is a valid parenthesis which opens as well as close. Okay, let us check another example. We have this example which is a closing parenthesis and opening parenthesis. So count of opening is 1. Okay, so if I check in another opening parenthesis over here, so if there is another closing parenthesis, okay, so the count of closing parenthesis is like that. Opening parenthesis is here, opening parenthesis, closing parenthesis is here. So a valid parenthesis, if you check, the valid parenthesis is 4, 2 opening, 2 closing, 2 opening, 2 closing, 2 plus 2 is 4. Okay, so how we are going to solve this particular problem? It's not a very difficult problem as long as you understand that we can use and solve this with the help of a stack. We can use and help solve this with the help of a stack. So what I'll be doing is, just a second. Yeah. So what I'll be doing is, first I can return. So this is the length, right? So I can write a function as int maximum length. Okay, maximum length. What I can do is I can pass a string. I can pass a string. Okay, I can pass the string as string s. What is my? I can take a max length value. I can take a max length value. Initially it will be 0. Okay. Now I'll be putting the stack which will store all the counts of the valid parentheses. So I can write stack of integer. Okay, it will store the indexes of that particular parenthesis. Say abc equals to new stack, equals to new stack. So I have taken all the stack values. Now what I'll be doing, I'm putting -1. I'll be initializing stack dot push. What I can do is I can push -1 in the values. Okay, in the stack. Okay, I'll be putting initially my stack as -1. So if I have a stack, everything will be -1, -1, -1, -1 like that. Okay. Now it is saying that push the -1 value into the stack. After that, we will traverse to the stack. Okay, we'll traverse to that particular string. So if this is our string, if our string is like this, that this, so then this, and then this. Okay, so this is 0, 1, 2, 3, 4, 5. Okay, so we are going to traverse to the string. How we are going to do? We are going to run a loop. Okay, I equals to 0 to, this loop will run till the length of that string. So I can say s dot length. Okay, okay, this loop is going to run till the length of the string. Now I'm going to check whether my character is a opening parenthesis or not. So what I can write, if s dot caret of I is equals to an opening parenthesis. If it is an opening parenthesis, what I will be doing, I'll be putting the value. If it is an opening parenthesis, I'll be putting the value into my stack. So if it is a stack, the opening parenthesis gets pushed. Okay, so what I'll be writing, abc dot push this particular parenthesis I, it will be pushed in the stack. Okay, if it is not an opening parenthesis, that means it is a closing parenthesis. That means it is not an opening parenthesis. That means it's a closing parenthesis. So I'll be writing an else block. I'll be popping this particular value. Means I'll remove this value. Okay. So what I'll be doing is, so I can write abc dot pop, abc dot pop. Okay. So it will remove the top element. It will remove the top element like that. Okay. Once my abc is being popped, what I can do? What is the next thing I can do? What is the next thing I can do? So what is the next thing I can do? I can check whether my current string is empty or not. Whether my current string is empty or not means in this particular condition, if I remove this only, the string is empty. So I will check if my stack abc is empty. Okay, it's a function. I will check whether my stack is abc is empty. Okay, is abc is empty. So what happens when this thing is considered as empty? What happens when this thing is considered as empty? What is my next thing? What I will do is I'll push the element next to it. That means I'll be pushing the value over here. In this case, we have a first bracket. Over here, we have a push first bracket. So what I will be doing, abc dot push. Okay, I'll push the first bracket. Why first bracket? The first is being done already. So it moves to the else block. It moves to the else block, and we have removed that particular one. we have removed that particular one. Okay, so sorry, I was explaining this particular thing. Okay, so again we are going to see it's empty or not. Yes, it's empty. We have removed one, so it's empty. So we are going to push another element. So we're going to push another element, which is the second one, is this one. Okay, this one. So once we are done pushing it, what we can see is we have pushed an element. Now how we have to check the maximum length till that particular position? We have to check the maximum length till that particular position. If it is not, if it is empty, then we are going to push. But if it is not empty, suppose the stack has this and the stack has this and the stack has this, so when it is not empty, in this particular case, if I take an example where it's not empty, I'll be writing another else block. I'll be writing another else block where I will calculate the maximum length equals to mat.max of max length comma I minus of stack.peak. So what will I minus of stack.peak do? What will I minus of stack.peak do? So you have to understand this particular line. You have to understand this particular line, that whenever I'm doing I minus of stack.peak, it means that I'm taking the top element again. But what is I over here in this case? I is something. I is suppose the string is like this. Suppose the string is like this: first bracket, second bracket, third bracket, close bracket, like that. And my I stands over here. I minus stack dot peak. I minus, it is saying I minus stack dot peak. You have to find the length till this position. So what I have to do? I can check. It will calculate the length of the current valid parenthesis sequence and update it. So we are doing stack.peak. We know already peak element will remove the top element and it will check the length till that particular area. Similarly, we are doing I minus value because obviously we can just see the previous lengths and then calculate the maximum length like that. Okay. So it's a simple code. We are going to try to explain this with the help of the code over here. Okay. So what is my first task? I have to create max length value and then I have to create a stack and I have to push -1 in all the elements. Okay. So I can write in max length equals to 0. Then I have to create stack of type integer. Equals to new stack. Okay. Once I've created the stack, I'll push the elements. So I can write abc dot push of -1. abc dot push of -1. Okay. Once I've pushed, what I can do, I can make a loop run through it. Int I equals to 0, I less than string. In this case, we have capital S. We can make it small s. I can write s dot length and then I plus plus. Once it is done, I have to check whether my character is a first bracket or not. Okay. So, but before that, do I have any check? No. I have to just write like that. Okay. So what I'll be doing is if s dot caret of I equals to within quotation first bracket. Okay, a first bracket. Okay. In this case, I'll be pushing the elements to the stack. So I can write abc dot push of I. Okay. In the else part, first I will be doing stack dot pick. Stack I will be writing abc dot pop. After that, if abc dot is empty, okay, the stack is empty, what I'll be doing? If the stack is empty, I'll be pushing an I. I'll be pushing the value which is present over there. So I can write abc dot push, same thing. Okay, the stack is empty. Else, now comes the interesting part. Else, what I'll be doing? I'll be storing my max length, right? So I can write max length equals to math.max of the max length, comma I minus abc dot peak. Okay. So I've done the else block, the for loop, can return max length, can compile. So we have successfully completed today's problem statement. It was an easy problem statement. It is just hard because if you don't know the concept of stacks, it will make you hard. Okay. So make sure you like, share, and subscribe to this particular channel. And thank you so much for viewing this particular solution.